So today, for my wicked problem, I'm going to speak about the climate change in the Mekong area, how wet weather and its consequences have influenced the agricultural problem in this region. So first, I'm going to talk about the context. The Southeast Asian region is responsible of 12% of the world's GHG emission in the 2000s, and we gotta know that it's also 4.5% in the Greater Mekong sub-region, GIG emission in the 2008. The problem with these results is, as you can see in this graph, the Greater Mekong sub-region is one with the most fast development progress in the world, so it's not gonna be better in the next future years. You can see across the Greater Mekong region, temperatures have risen from 0.5 to 1.5 degrees in the past 50 years and continue to rise. The most recent models suggest continued warming, increasing climate variability, and more frequent and damaging extreme weather events. Another big problem is the wetter rainy season, who are expected to lead to increased flooding, and drier dry season will exacerbate water shortages. So, moreover, the reliability of climate cycles, such as the onset of monsoon precipitation, may be shifting, and these trends are likely to accelerate and intensify in coming decades. The sea level rise is threatening the region's coastal communities, adding stress to coastal ecosystems such as mangroves. These have already suffered from large-scale conversion from shrimp and fish aquaculture and for whale conservation also. So all these three problems leads to this kind of phenomenon. The stress weaken ecosystem resilience, like the capacity of ecosystems to bounce back or recover from disturbances and damage, which makes ecosystem even more vulnerable to climate change, a downward spiral that ultimately has serious consequences for humans. So for this problem, we're gonna focus mostly on Vietnam, which is the country which is the most touched by this problem. The Vietnam population is about 92.7 million people, and there is 57% of this population who are farmer or are depending from the farm living. So how the climate change influence Vietnamese farmers, and what has already been done to change it is actually the problem we're gonna focus on, because, as I said just before, the problem is mostly in this region of the sub-Mekong area. Salt water has two problems on the rice cultivation: absorbing. When it does, it is sudden that the salt solution actually draws water off the plant, and the salt poisoning. If too much salt interferes with the chemical processes the plant uses to spread nutrient and convert chemical into useful sugars. So there is poison. Nowadays, there's around 4% salinity in the water around the Mekong Delta, and the problem is the seawater rises by 30 centimeters as it expected. More than 50,000 hectares of agricultural land in the Mekong Delta would suffer from the saltwater intrusion. That would imply 100,000 tons of rice lost. Today, the Vietnam is the third exporter of rice in the world, but the problem is that the salt tolerance is an important constraint for rice, which is generally categorized as a typical glyconophyte. Soil salinity is one of the most major constraints affecting rice production worldwide, especially in the coastal areas as Vietnam. So the solution adopted today, as for example, the diversifying plantation to make it suitable to the different conditions of the land areas, has been considered the long-term solution to get adapted to the climate change. The susceptibility or tolerance of fly plants to high salinity is correlated action of multiple stress. Another solution adopted is the rotational rice cultivation and shrimp hatchery model that should be applied to the areas with the long salinity intrusion time and high salinity. The areas with the salinity intrusion duration of more than 7 months a year should turn to shrimp farming area, as this diagram explains the functionment. Solutions don't attack the problem at the root, and this is why projects as the Mekong Delta Water Resources Project, developed by IDEA, sought to develop water control infrastructure to prevent salinity intrusion and promote irrigation, drainage, flood protection, and improved rural drinking water supplies. Drainage, flood protection, and improved This project was divided in 5 sub-project areas covering more than 500,000 hectares. As the results, the freshwater supplies for irrigation were substantially improved along with the ability to control salinity and floods in the Mekong's delta. Improved along with the ability to control salinity. Another project similar and complementary to this one is the cooperation between Cambodia and Vietnam, the Mekong Delta water issues. It's supported by the Mekong River Commission and funded by the World Bank for $354,000. First measure is the flood and drought strategic planning, a strategic transboundary water resources management plan that could improve the understanding of hydrological requirements in the area and ensure the coordinated operation of upstream reservoir and harmonious development of the irrigation infrastructure. Second measure adopted is the infrastructure development and investment, and the coordinated development of flood control and irrigation systems such as dikes and embankment could cause floods and drought in other areas of the floodplain and may result in water pollution and shortages and less agricultural production. Finally, the environmental, social, and economic impacts of development and climate change. Information gaps of the flow regime, hydrological modeling, and other tools for impact assessments need to be filled immediately to minimize socioeconomic and environmental impacts of water, infrastructural development, and global warming.